All right, good morning, ladies and gentlemen, or good afternoon. So we're going to talk about assignment C, give the directions how to solve assignment C. So let's go with red. So what we're doing, if in cases you come to a point and you're working on Lewis dot structures and you notice that one of the atoms does not have 8 around it, we're going to have to do something to deal with that because you need to have 8. So to do that, we move a pair of electrons from basically one of the outer atoms to share with the middle atom, forming a double bond with 2 lines. So if I look at something like this, for example, I need 2 here. I'm going to take this one, move it to the center, and so we end up with a C double bond O. This is what we mean by double bond. 4 electrons or 2 pair of electrons being shared between 2 atoms. And so this is what we're talking about. This is really not a structure. There's more wrong with this, but we'll talk about that later. So this is what we're doing. So let's look at carbon dioxide. Let's go ahead and form the Lewis dot structure for this molecule. We've got 1 carbon. It has 4 electrons. And we've got 2 oxygen. Each of those have 6 electrons, so 6 times 2 is 12, plus 4, that's going to be 16 valence electrons around it. 2 times 6 is 12, plus 4, that's 16. So carbon's in the middle. We have 1 oxygen on one side, 1 on the other. Let's draw the single bond between the carbon and oxygen. Remember, the oxygens are not bonded to each other. So now let's look at this. We have used up 4, so minus 4, we have 12 electrons left. 1, 2, 3, 4, there's 6. 1, 2, 3, 4, 5, 6. So we used up 12, and we got no more left. So it looks like a lot of students will say this is a stable Lewis dot structure. This is the correct Lewis dot structure, but it's not. Even though each oxygen has 8 electrons around it, carbon only has 4. It wants 2 more. So what will happen is that we're going to take 2 of these electrons from this oxygen and move it to form another bond between this oxygen and carbon, and do the same thing over here and move it over. And so the net result is C double bond O. And here's another double bonded oxygen. And this is now the Lewis dot structure for carbon dioxide. Carbon has 2, 4, 6, 8. 8 electrons around it. 4 pairs. 2 of them are bonded to this oxygen. 2 of them are bonded to this oxygen. And carbon has 2 double bonds attached to it. Oxygen has a double bond to this carbon, and it has 2 unpaired electrons. 2 sets of unpaired electrons, 2, 4, 5, 6, 7, 8, and the same thing with this. So this is a valid and correct Lewis dot structure for CO2. And this is how it works. Now let's look at NO2. Oxygen, we got, again, has 6 valence electrons. We got 2 of them. So 2 times 6 is 12. Nitrogen, well, it has 5 valence electrons, so we have 1. So we got for a total of 5. And then it's negatively charged. So we're going to add 1. So this will give me 18 electrons. This is important. So again, nitrogen is to the left of oxygen on the periodic table, so it goes in the middle. Let's put 1 oxygen over here, 1 oxygen over here. Draw a bond between the 2. 2, 4, so we used up 4. And that means we got, 14 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I'll put 12 around these oxygens. That means I've got 2 electrons left. That goes around nitrogen. And I use those up. I got none left. This oxygen 2, 4, 6, 8. Yep, this oxygen has 8 around it. 2, 4, 6, 8. This oxygen has 8 around it. Remember, each oxygen, this one C6, owns 6, but it sees 2 more for a total of 8. This nitrogen 2, 4, 6, it's missing 2. So we're going to pick one. We're going to take this pair. You can go from this side too, it doesn't matter. We're going to move it in between. So we have oxygen, nitrogen, whoops, got to do the double bond, and there's our other oxygen. And now we have a balanced Lewis dot structure, the correct Lewis dot structure for Ni2 minus 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Every element has 8 electrons around it, and it's good to go. So this is the correct version of NO2 minus. This is called the nitrite anion. We'll talk about the naming of these later in the chapter. Right now we're just making molecules. Now, what we're going to do is I'm going to show you the difference with this NO2. This is called a radical molecule. So NO2, again, N has 5 valence electrons, oxygen has 6, but we've got 2 of them. 12 plus 5, that gives me 17. So we've got an odd amount of electrons present. We've got to do something a little different. Again, put each oxygen on the side. 2, 4. So we're going to have 13, I believe, around nitrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, In some of these hard problems, you will never get 8 around an atom. What will happen is you want to get close to 8 as possible, so move this over. So oxygen, double bond nitrogen, single bond oxygen. And we got hydrogen electron up here. This is called a radical, which has a 1 unpaired electron and it's very, very reactive. And so this is something you need to realize, is that this can happen. And that's it for this slideshow. If you have any questions, please email me or see me during Zoom. Thank you.